Hi, I'm Jacob Ison. This is Jordan Buckler and Gary Smith at the camera. This is our design project for the Electromechanical degree at Shawnee State University. The purpose of this project, of course, is to encompass all the different points that we've learned in the degree here at Shawnee. But this specific problem and this design was more or less designed based off a block. We were given a block and, okay, we need this piece produced. Make us a machine to do it. And so we devised this apparatus to be able to do this as a sort of an industrial control example. What this machine does, more or less, it puts a block in the clamp closes in on the block moves to the first position, the drill goes down through the block, comes back, the cart then moves to the second position, rotates the block 90 degrees, drills a second hole, the block rotates back 90 degrees, moves 1 more inch in, and then drills the third hole, and then the carriage retracts back to the home position to where you have a finished product. We'll demo it in just a second. A few brief points about the machine. It encompasses all the points that we've learned. We've got electronics, electricity, we have pneumatics, we have a PLC that controls all these discrete individual components and puts them together and creates the overall picture and presentation of the product. We have our control panel here with all the different indications you would see on a normal industrial control. We have a light that indicates when the power is on, a light that indicates when you're to load the block into the carriage. We have a pneumatic indicator that indicates when the block is clamped, a light that when the drill is running, and a light when the cycle is in progress. And then also we have an electric counter here with a manual reset that indicates how many cycles that the machine has went through up to a certain point. Okay, and turn the air on, Jordan. We'll get ready to show you a demo here. So you have our block that we place in the cart. Alright, the block's clamped, the cart moves into the first position, drills a hole. Second position, rotates, drills the second hole. Rotates back, third position, drills that hole. The carriage now retracts to the home position, and you have a finished blank. And we'll show a little bit of it here. You can see our drill feed. Our drill motor here is controlled by the limit switches. We have our carriage here with our pneumatic actuating cylinder here, and then our clamping cylinder. Rotate it around. Here's our feed motor with a 200 pulse encoder. Here's our pneumatic control valves, solenoid valves, our air supply regulator, flow control. And then here's our control box where everything comes together. We have our Automation Direct DL06 PLC we use. Everything comes together to this. It controls all the specific parts together. We have our power supplies, we have our encoder inputs, our full wave bridges, rectifying bridges, then we have our LMD 18200T H-bridge chips that control the direction and speed of the motors, and then we have again the inputs from the PLC. This is the total project, the culmination of 15 weeks that we have took to construct this thing, and it produces the wood blanks as an example to an industrial process which the whole degree comes down to and tries to leave the person with an effectual ability to be able to create such things and work on them.